Solid mensuration. So there are two classifications of polygons. We can have convex polygon. Example is a triangle. So this one is a convex polygon. And we also have a concave polygon. Example, this one. So the difference between the two is, for convex, all interior angles are less than 180. But for concave polygon, at least one is greater than 180 degrees. So that's why it's convex polygon, and then we have concave polygon. So this one is your interior angle, and what you see inside, these are your interior angles. So the blue ones are exterior angles, and then the inner one, that's your interior angle. So as you can see now in the figure, the exterior plus the interior angle should be equals to 180 degrees. So they are linear pair. So for polygons with n sides, for regular polygon, so when we say regular polygon, it has the same sides. Example, square, pentagon, hexagon, heptagon, octagon, nonagon, decagon, ondecagon, dodecagon. Those are all regular polygons. So for regular polygon, we can use this formula. So in finding the number of diagonals, so we have n over 2, n minus 3. For interior angles, n minus 2 over n times 180 degrees. Sum of interior angles, n minus 2 times 180 degrees. Sum of exterior angles should be 360 degrees. So meaning this n here is the number of sides. For example, for square, so the number of sides is n is equals to 4. So the number of diagonals for square is 4 over 2, 2. So the number of diagonals is just equals to 2. So interior angles, so if you're going to compute it, so 4 minus 2, 2 divided by 4, 1/2 times 180, that's 90 degrees. Sum of interior angles, so 4 minus 2 times 180. So we can also compute that, and sum of exterior angles is 360 degrees. So you can use this whenever you encounter regular polygons. So for circles, so the area of a circle is pi r squared. We also have circumference, 2 pi r. Circumference is the length of the part that surrounds it, the center. So this is your circumference. Sector, so the area of a sector, so later on we will see what's a sector. Arc length, r times theta. So theta here should be in radians. So in order to convert to radians, all you have to do is to multiply the angle by pi over 180 degrees. Segment area, so this is the area of the segment. So this is 1/2 r squared theta minus sine theta. Theta here should also be in radians. So this is your sector. So the sector includes, so the central angle subtending that particular arc. Then you have a segment. This one is your segment, and then the arc is the length. So this is your arc. So you can see the formula for the sector, the arc, and then the segment. So this is how you get the formula for these parts. And then the parts of a circle. So you can also read on the different parts of a circle. So some key formulas and theorems for circles. So the central angle is equal to the arc. So for example, the central angle alpha is equals to the arc, this arc here, the intercepted arc. The inscribed angle is 1/2 the central angle. So the inscribed angle beta, so in this case, the inscribed angle is theta in the illustration. So the inscribed angle is just 1/2 of the central angle. So the central angle here is theta, and then the inscribed angle should be beta. So beta is 1/2 of theta. And then the angles subtended on the same arc are equal. So as you can see, so all the angles subtended by the same arc are all equal. You can see in the figure, for example, for D, the angle subtended by the arc BA, so this is just equals to, these are all equals. Subtended by arc by D, E, E, F, and G, these are all equal. Okay, the area of a triangle inscribed in a circle. So this is a triangle inscribed in circle. So meaning the circle is inside the triangle. So when we have a circle inside a triangle, in order to find the area of that triangle, we just have to multiply the radius of the circle, so the radius of the circle, by the semi-perimeter of that triangle. Semi-perimeter, for example, if this is 1, if this is 2, this is 3. So in order to find the semi-perimeter, just add 1, 2, and 3, then divided by 2. So the S here is equals to 1 plus 2 plus 3 divided by 2. So that's semi-perimeter in order to find the value of the area of the triangle. However, if the triangle is circumscribed in circle, so baliktad, so the area of a triangle is ABC. ABC, these are the sides of the triangle. R is the radius of the circle. So for parallelogram can either be this one, a rectangle, square, or rhombus. These are called parallelogram because two sides are parallel. So for parallelogram, the area of a parallelogram is just the product of the two sides, two adjacent sides. For example, this side and this side, so adjacent. This side and then this side, this one, and then this one. So the product of that adjacent sides multiplied by the angle between them. So for rectangle, the angle between them is 90 degrees as well as for square. For rhombus, this is different. For parallelogram as well. So you need to have this data, the angle between them and then the sides, so that you can get the area. For the perimeter, this is just twice the sum of A and B, or basically the sum of all the length or the sides. This is your perimeter of a parallelogram. For a rectangle, so the area of a rectangle is just A times B, or the side, this side, and this side, because sine 90 happens to be 1, so that's why it reduces to this form. And then for square, so the same also with square. This is A because the sides are equal. So A times A, so A squared, sine theta, so that's 1. So that's why we have A squared. The perimeter is A, then plus A, another A side, and then another 1. That's why we have 4A. For rhombus, so when you see two sides, for rhombus all sides are equal. It's just that unlike the square, rhombus is this is inclined, or the angle between the two sides is not equal to 90 degrees. So these are still A. It's just that the angle is not equal to 90 degrees. That's why we use A times A sine the angle between them, which is theta. So this is the area, and then the perimeter is the same as that of a square. For trapezoid, so for trapezoid, so the area of the trapezoid is just 1/2 of the parallel, the sum of the parallel bases times the height, the perpendicular height. It should be perpendicular. So that height, this one, should be perpendicular to the base, to the two base. So A plus B times height divided by 2. The median, this part here, is equals to 1/2 A plus B. So as you can see, area is just the median times the height. For cyclic quadrilateral, so this is an example of a cyclic quadrilateral, a quadrilateral that is found inside a circle, so with sides A, B, C, and D. So in order to find the area of a cyclic quadrilateral, we will use Brahmagupta's formula. So Brahmagupta's formula, S is still the semi-perimeter, or the sum of all the sides divided by 2. So in order to get the area, and once you have the area, you can get the radius. This one refers to the area of the quadrilateral. The area of a quadrilateral. This one is the radius of the circle. For the radius of the circle, this is the formula. This area here is the area of the quadrilateral. Ellipse. So for ellipse, it's just pi times A and B. A and B, this one is the semi-minor axis. B is the semi-major axis. So the product times pi is the area. While the perimeter, we use this formula. Polyhedrons. So polyhedrons are three-dimensional. So for polyhedrons, what we will get are the surface area and the volume. Example of polyhedrons, you have your tetrahedron, cube, octahedron. So the tetrahedron, this is the surface area. These are the formula for surface area, the volume, and then the ratio of the surface area to the volume. So for rectangular parallelepiped, so this is a rectangular parallelepiped. The volume is just the product of all the edges, A times B times C. The surface area, so the surface area, this refers to the whole surface. It's just twice of the sum of these products here. The lateral area refers to the area of this part here and the other one. So that's why it's just 2 times BC plus AC. For cube, so the volume of the cube is the sides to the power of 3. Surface area, so since we have 6 sides, and the area of each side is a squared, so 6a squared. That's why we have 6a squared. The lateral area does not include the base, so that's why we have 4a squared. Right prism. So for the right prism, it's just area of the base times the height. So this is your base and then the height, L. So the surface area is the lateral area plus twice the area of the base. So twice the area of the base because we have 2 bases. And then the lateral area, the one that surrounds it, this part here, those are your lateral area. You can solve that by using the perimeter of the base times the length. The right circular cylinder. For right circular cylinder, the volume is pi r squared h. Basically, it's just the area of the base times the height. The lateral area, or the lateral sides, those are twice your pi r L. The surface area is this 2 pi r L plus 2 area of the circle here.